Hello, everybody.
Hey, good to see you, Gowtham.
Good to see you, Krista. How are you?
Good.
I haven't seen you for it's almost 2 years. I don't think I've spoken to you. It's great.
I know. It was
Not great.
face-to-face, I think. Yeah, last time. So you're doing some interesting phenotype work?
Yeah, that's becoming that's the primary work that I'm doing now. I'm very excited about it.
Me too.
Now
Christoph, you consider that your primary work now? Is that?
Well, yeah, it's become that way. We've been working on these problems of noisy labels in phenotyping work. How do you detect the presence of various medical conditions when they're not coded? And there's a lot of machine learning stuff that goes along with that. It's been challenging.
How long have you been working on this effort or this project?
You know, it probably started back in 2017, and it's just sort of evolved, yeah.
And now it sounds like one of your primary initiatives at this time.
Well, it wasn't the goal. Like we needed good phenotypes to do our comparative effectiveness work, and then the more we struggled with those data quality issues, the more it became where we got pulled into. So, but it's been fruitful. So, what are we going to talk about today in general? Is Juan?
Hello.
Juan there? Hey.
Yeah, so the intent of this one is like a breakout session. There is no structure to it. It is for us to all talk about our experiences and then come up with some ideas. It's a brainstorming session. We all have this problem of phenotyping. We all want to build better phenotypes, whether it is rule-based phenotypes using a tool like Atlas, or whether it is probabilistic phenotypes like using like a tool like Phentoype. But this is a problem that needs to be solved. And if we don't solve this problem, then all the downstream work, including estimation, prediction, or characterization, will not be as effective. So we all agree that this is a foundational problem that we need to solve. So how do we come together as a community, join forces, and solve it? That's essentially what we need to tackle. As a community, we have a phenotype work group, but that work group is non-existent. It's just a name right now. So how do we formalize it? Do we need need to have weekly or monthly or quarterly meetings? How do we lead that? How do we discuss it? How do we set the agenda? What are the topics of interest? Everything is in scope. Essentially, I see this as a 2021 kickstart to phenotyping as OHDSI. That's my take of whatever you want to do. Juan, what's your thoughts?
Yeah, exactly like you were mentioning. We kind of see what people are doing, what people are interested in doing, and how do you feel that this has evolved or it hasn't evolved over the past few years. We kind of want to have everybody together. That's to kind of formalize how we push forward. Because we try to restart it. 2 people shut up. We try to restart it again. 4 people shut up, and so now we're trying to pull a bigger audience because everybody is working on some sort of phenotyping. But we haven't really aligned, or COVID hit and then everybody forgot about some of those efforts. So basically we want to hear what you guys think, what you guys want to do or are doing.
Right.
Don't be shy.
Christopher, you gave us some examples of not examples. You started the conversation by talking about your experience. Before you go into more details, is there anybody else in the call that is actually working on phenotyping right now?
Phenotyping?
Yeah.
Most of us.
Yeah.
So what type of phenotype is there a problem that you want to talk about? Anybody working on a project right now that that they're stuck?
Well, let me give you an interesting example of how actually the OMOP common data model has become, the vocabularies have made some real challenges. So we're working on the detection of uncoded self-harm. And that's a broad umbrella that includes attempted suicides and also ways you could injure yourself. That's not necessarily trying to kill yourself. When you map the billing codes from, I say, ICD-9 and 10 into OMOP, there can be billing codes that ascribe intent to harm oneself, that then lose that intent, or create a one-to-many mapping. You know, like basically because there's no intent that goes with a particular form of self-harm in SNOMED. So we've run up with, you know, if we just counted on mapping everything to SNOMED and then blindly going ahead with trying to impute self-harm, we get into all sorts of trouble, and we've gone down some real bunny trails that way. And then the second area that we've struggled with is procedures not having a common vocabulary. That's, well, the best we've been able to do is basically map all the ICD-9 procedures to ICD-10 and all the CPT-4s 10, and we're doing like a one-to-many that can be like 50 different codes that a given CPT-4 might map to, and then use that as covariates in machine learning. So we struggle with, you know, wanting to have a common vocabulary that we could define a phenotype with, and procedures are really an area that still is a pain point. But I'd say it's the vocabulary mappings in general. We almost find that it's almost counterproductive to use OMOP, that you have to pretty much know your source vocabularies inside out and OMOP inside out, and you get in all kinds of trouble if you're not aware of those mappings. So
Christoph, let me, as a follow-up to that comment, if you were only using source codes, that is ICD-9 or ICD-10, to identify self-harm, do you think you would be able to identify cohorts of people that meet the criteria with the sufficient level of accuracy that you need for your study?
Well, you'd have to basically split by time, you know, prior to when they adopted ICD-9, you'd do the covariates that way in 10. So if you want to put everything together and harmonize it, then no. And so we do use OMOP to you know, harmonize covariates. And so that's, but in part it's been just this, well, anyhow, I don't want to go too deep into the weeds. What? Oh, go ahead.
Yeah, this is Chris. I have a comment for you just because I happen to be working on the same exact problem. Actually, I worked on it 2 years ago, and then we decided we'll just use source codes for one particular use that we needed inside J&J. And just, it happened that last week I revisited this problem. I don't know if you heard about cohort diagnostics. That's a tool that Gowtham and Anna and the team had been working on to dig into phenotypes. But I use the tool now to look into how is missing some of those mapping problems, how does it show up in the data in terms of who are the people am I missing, what do they look like, are they exactly, all these different things that cohort diagnostic kind of explore and put clear to the user using like empirically showing you the data. And actually, I came to the conclusion, and I'm very confident about it, that you don't have a problem in that particular case. There might be also a change in the mapping in the 2 years, that maybe now with covering almost all the self-intent harm that on the ICD-10, they actually map to something in SNOMED that you could capture. I can talk to you on separate about this, but I have it, and I wouldn't have reached I wouldn't have known that didn't I use cohort diagnostics, because there's a lot of complexity, so many codes that are missing. But yes, so maybe if you talk about a little bit about cohort diagnostics and how can you use it to inform if there's an issue with mapping, or how big is the problem in terms of like empirical data.
Well, on a related note, we found another problem. At least it's, we've been using the ETL CDM builder for Truven market scan data, and all the deprecated codes that are actually present in our data are mapping to concept 0, and so there are hundreds of procedures, especially that as well as there's particularly some poisonings and so forth that don't map to anything, that are sitting as source codes, and we see this also in the VA data that's used the latest greatest relationship mapping. So you'll see deprecated codes are there, they don't map to a concept ID, and therefore there's no relationship concept relationship mapping to anything. So there's a bunch of orphaned historical information that's not carried forward because code got deprecated in 2015, and it makes no sense to me why that is the case. So I'm just find that I can't trust OMOP mappings.
But that's fixable, isn't it?
What's that?
That's fixable, isn't it? If you find the code that's mapped to 0, you can talk
in a
to
way.
the vocabulary team.
Here's the issue. Like, you'll see, like, here's the concept. The source concept is sitting there, right? But you don't necessarily know what vocabulary it came from, because that's been lost in the mapping. So you have to go back and redo your ETL to clean these things up.
Christoph, when you're ETL'd OMOP CDM, does the field condition source concept ID have that source concept ID in it?
It does.
So does it have a concept ID? Okay. So
right.
in your case, the condition
it'll be like an ICD-9 without a decimal place or something, or a CPT, and it can be kind of ambiguous even what vocabulary it comes from.
So you're saying this is a scenario where your source code has a concept ID, a source concept ID, but it does not have a mapping to a standard concept ID.
Right.
Okay.
Well, it doesn't map to a source concept ID. It maps to 0, even though it's actually sitting in the concept file as a deprecated term.
Got it. So I think there's two issues here. One is the vocabulary issue, where you're saying there is a concept ID for that source code, but it does not have a corresponding standard attached to it, which from my understanding should not exist. So all source codes should have some standard concept ID attached to it, should not be just 0. So it could potentially be an ETL issue.
There's no deprecated concepts appear in the concept relationship table. That's the issue. And deprecated concepts are a fact of life, that they were used at one time, and the fact that they no longer are used doesn't change that someone was using that for billing purposes 10 years ago.
I think this is a good conversation to have with the vocabulary team, especially with Christopher Reich. So I think he may have some ideas, because I remember some approaches to make sure that those older deprecated codes are not removed from the vocabulary mapping. So there were some discussions there. Now, regarding the process of building cohort definitions and phenotypes, have you attempted to use cohort diagnostics for your work?
No, I have not.
Are you familiar with cohort diagnostics, or have you seen cohort diagnostics?
I'm familiar. It was used in the COVID projects. So I have, but I wasn't part of those teams that were doing that work.
there is some intelligence that cohort diagnostic offers up. So when you build a cohort, as you know, there is a cohort start date and a cohort end date. So it's useful to know what happens on the cohort start date or the index date. What standard codes exist on the same date. What non-standard codes exist on the same date. So if you find that there are people with a lot of non-standard codes for some reason, but without a corresponding standard codes, that might be an insight for you. So this also tells you types of visits that they were experiencing, and so on. So I think core diagnostics might help you have some feelings about whether the course that you're building is directionally correct.
Yeah, and I think in general, sort of stepping outside of this particular problem, there are so many nuances of stuff like this that I've been working with OMOP CDM for more than 5 years now, and I think of a newbie coming in and going through all of these pain points and challenges that there's so many pitfalls when you get into the advanced work with trying to engineer features and phenotypes and so forth. I wonder how we can pave the way for newer people so they don't have to experience these frustrations.
There's one. The idea behind a phenotype library is to make good quality phenotypes and cohort definitions available for others to use, so that not everybody has to do the same thing of cohort building over and over again. In this call, we heard from Aza Shaibi that she's been working on a similar project. She's got experience with cohort diagnostics. Maybe there's an opportunity to collaborate there.
Yeah, and even the other problem that Chris mentioned about procedures, I know Evan is here and he worked with us. We worked intensively on the procedure situation. In that case, we were trying to phenotype surgeries and different classifications of surgeries. And it's true, we had big issues with the procedures. Maybe because of mapping, maybe because it's also hard to code and many other issues, but it is another topic that we might want to tackle in terms of how phenotype surgeries or phenotype certain procedures that we know are of interest for the community and for different collaborators that we want to know, and we know it's hard to do. So that's another thing that we might want to tackle.
Yeah, Chris, I'd be happy to chat about the procedure space. Obviously it's going to be a big domain, and the problems that you're having may very much relate to a particular use case. For us, it was a challenge of phenotyping around this concept of major non-cardiac surgery. That's a big area of practice, and risk, the evaluation of risk models, particularly the revised cardiac risk index that was looked at for the OHDSI study-thon this year. And I think you highlighted a few of the kind of the issues in the procedure space that are probably shared issues, and there's actually probably a lot of work that can be done subsequently to having better defined cohorts within the procedure space.
Yeah, this is Arsi Allen. I used to work at FDA CDRH, and now I'm at NIH. So I'm co-chair the OHDSI Medical Device Working Group, but I have been feel your pain about all these procedures. I think I like the OMOP have those mapping already for other codes, but I read the OMOP some pages says that procedure codes just is all over the place. So they didn't have an effort to harmonize. So I think maybe this could be an opportunity for us, people who really wanted procedure codes to be harmonized, to organize together and start a working group or some kind of effort to work on that. And then other things, my experience of, because I was involved in a couple of couple of FDA projects that utilize claims data to identify, working with a couple of industries to identify certain procedures, basically identify a cohort. And it is a very time-consuming work, and each industry has totally different understanding of how they will categorize the phenotype or cohort that they decide to. So I think we need to form a group to discuss how to proceed. What's the priority, what's the goal, and the sort of things like that.
And I think this is cross-cutting into the machine learning group that's meeting right now, right? I mean, if you're trying to use covariates to describe patients and you have several coding systems for procedures that aren't harmonized, it's a problem.
Right. I agree.
There is another angle to this covariate conversation, Christoph. Right now, most of OHDSI covariates are based on concept IDs. So your presence of this source standard concept ID or this standard concept ID. In the future, and there are already some work over here, why not use another cohort as a covariate? Why not use cohorts as covariates? So a cohort will give us more granular control on our definition compared to a concept ID. And so using a cohort as a covariate would probably help improve our models. Using cohorts as covariate is also a phenotyping challenge, because now we are in every covariate, if every covariate is a cohort definition, then maybe we can use a tool like the phenotype library to pull down the cohort definitions and use those cohort definitions as covariates in the model.
So hi, this is Kees. I guess another example that I can bring in is the phenotyping as the bridge between the clinical definition, or the way that clinicians view the progression of the disease, versus what you can find back in the data. So in the second week of March, we are planning this new study-a-thon on prostate cancer. And the idea is to identify watchful waiting patients. So, essentially every patient where the clinician has decided not to intervene. It's not a curative intent. And there's even a Delphi consensus papers on what is active surveillance, what is watchful waiting, and the clinicians, they can totally explain to us, given this patient, that's definitely watchful waiting, or that's active surveillance. But now we have these lists from them, with terms like, well, if there's a biopsy and there is no intervention such and no intervention such and so on, then I would call it watchful waiting. Now the challenge we have is, how do we translate that into data, into actual codes? And this is actually very hard. Christian Reich and some others are now involved in sort of a sub-team preparing or trying to come up with the core definitions. And anyone, by the way, who wants to join that is welcome. We have a Pioneer Study-a-thon in the OHDSI team's environment, where you can see what we're doing. But yeah, we haven't figured out how to bridge the gap yet.
Case, you bring up my favorite topic, which is there are all these informatics papers we haven't written about the ground truths of phenotypes that we always say we're going to get to, but they're not sexy and no one wants to write it. But they're always in my notebook of things I should do when I'm trying to get stuff done. But it may be worth identifying these, like, so Christoph, you were saying, how do we train people? Well, we give them the a priori knowledge and guide them through our failures and have that easily accessible, right? And maybe there's some ability to take and create a prioritized list. But like, my favorite is the ICU is not a place. Like, that will be a paper I write at some point. It's in your heart, it's procedures, it's other things that happen to you. But we have other heuristics we know from seeing the data And I guarantee you, I've looked across other federated networks, they don't really publish these either, even though we all speak and go on panels together. And this is a huge part of AMIA, right? We share it. We need to culminate these into lessons that we can, easily reference and then drive forward. And that's just, it's a fact. And then we say, here's our strategy, the best we can do today.
Patrick, I'm curious if you think this would be the forum to discuss some of the observations that you've made, or I'm attributing the insights to you, and they may have come up in conversations. But you've had some, I think really interesting ideas around, what should we do in the future around handling error in our that we know exists in terms of our phenotype definitions, and we could probably, we can find different ways of estimating it. And then, I think, as you mentioned, that kind of the current standard is to just subsequently ignore it and carry on your analysis as though that error doesn't exist, and you don't really kind of attribute any additional uncertainty to the error that was that you could initially estimate with your phenotype, and it strikes me as another kind of big woolly kind of body of work that that probably doesn't get the attention it needs, but could actually have a pretty big impact in terms of what we kind of ultimately attribute to error in a causal estimate or a prediction model.
Yeah. I mean, I guess at a very broad level, I would say that I think that there are two big opportunities. There's phenotype development, which is, I'd say, like what we've been talking about right now. How does one create appropriate code sets? How does one create appropriate logic that attempts to find some sort of definition that one could operationally use, whether it be as an outcome or a covariate or however you want to use the model? And then the second component is phenotype evaluation. How do we actually assess that whatever definition we got, however we created it, how do we actually assess that it's doing what we want it to do? And I think that the work that Joel's been working on, evaluating work that Juan's been doing with probabilistic phenotyping starts to try to get at this idea that we want to be more nuanced than just having a binary classifier and assuming that the binary classifier is 100% correct, but instead try to think about what error is. I think for our as a community, I think like there needs to be parallel tracks working on that, like to the point that Christoph's raising, like people are still struggling with the basic understanding of how to use the vocabulary and how to create good code sets, and so we need to work on that problem. But in parallel, I think we should be working on the evaluation problem as well, and start to think about what it means when we create a definition, but that definition may be subject to misclassification error.
Yeah, and I'm still also thinking on your comments, Christine, how, I mean, getting the word out and explaining some of the lessons learned, so to speak, would be one thing. Trying to actually define these ground truths. I suppose if you really want to define it, then you would kind of need a view on the clinical process. And the decision process of the clinician and how they see it. You would need to have a view on the data generation process, which, if claims, is really on the coding and on what can be declared and so on, right? And then the causal models, so perhaps even the causal graphs that you kind of assume to be behind these phenotype definitions and what you want to measure out of it. So that is a lot of work, and I don't think that's even done, given also the sorry state of data that we typically have. Does it even make sense to go through all that trouble if in the end what you're looking at is a often very crude definition in which we try to recreate the reality of what happened, so to speak. So from a practical perspective, I think what Patrick said makes sense to me. We can talk about how do you create cohorts, the definition of them, and what kind of code you use, and also how do you evaluate them. And then with the evaluation, I think is maybe where you have various categories, because also the type of studies can differ, right? The cohort that you need for a clinical characterization where you're looking at treatment pathways is a different cohort for if you're just assessing efficacy, let's say, or looking at adverse events.
Yeah, Keith, as a follow-up to that, you said when you start for your project, as the prostate cancer example, watchful waiting, you said the clinicians have an idea. How do you capture this idea from the clinicians? What's the initial conversation like? Or could you just very briefly walk this group through how would you build a cohort for a watchful waiting prostate cancer individuals?
Yes. Well, the easiest to start with is actually the guidelines, because this is also broadly the reference for the clinicians themselves. So for prostate cancer, and very nice work done by the Dutch Comprehensive Care Organization. They made a visible click-through pathway, if you will. So with prostate cancer, that starts with the first biopsy, right? And then it's basically a decision tree where you say, okay, give me the PSA value. PSA value below this, then you go this part of the tree, and if it's more, then you go that part of the tree, and then maybe you get some imaging going on, and eventually you get Gleason score, PSA level, all these things. So if you get a definition for the clinician, the way it would look like is, I would define I would need to look this up. Like localized prostate cancer to me is PSA level such, and a biopsy with that result. That's kind of the general outline of how a clinician talks about their definitions.
Mm-hmm.
The thing is that we don't necessarily see that back, all of those things in the data. They may just be in the clinical notes. Therefore, if we are looking at claims data, they won't show up.
I see. Okay. I see.
Actually, if you're interested, I'll put the link to a spreadsheet with the clinical definitions in the chat.
So it could be useful. So you just described case like how typically we would go about creating a heuristic-based phenotype definition. Juan, if you were to use prostate cancer as an artifact to describe probabilistic phenotyping, how would you similarly tackle that problem?
Well, yeah, no, that's a good point. And ideally, well, you find something, a heuristic or just to mention either codes, a set of codes, a set of, the stuff that you find in NLP, and, that will basically find your cohort using something like Aphrodite. So it's a lot less rigid, once you have a model. But it's you don't need that much of a structure. So I will start by using just a set of codes, or even just the actual string if you have NLP stuff in your CDM.
So you would create a reference set to train a model on based on just the occurrence of prostate cancer as the string, or a code of prostate cancer, for example.
Yeah, at the simplest stage, yes.
Yeah, that wouldn't give us anything for prostate cancer staging, let alone on watchful waiting, right? So, like it may be.
You have to break it into the pieces, though, right?
Yeah.
Because so to me, those are layering in complexity of more nuanced heuristics on top of a base heuristic, right?
Yeah, so you will use something like the anchors where, you find with your first, like the prostate cancer as your main anchor, and then you start refining based on, what other staging or what other, more specific things you want to find.
Juan, I'm curious with your, machine learning approaches to phenotyping, what you've done on quantifying uncertainty for phenotypes. Go ahead.
Can you repeat the question? I don't understand what you mean.
Well,
Sorry.
you can build a machine learning model and then go into a set of patients and say, well, here's ones that have a given, perhaps a probability according to our model. of whatever phenotype you have. But like, have you, say you're trying to say, here's the fraction of the population we think has this phenotype in a, in a holdout data set. What have you done, if anything, to quantify the bounds on such things?
Well, that's basically phenotype specific, right? I mean, we haven't done anything, generic, because there's no real way of doing generic, unless, you want to set up a framework where you actually do chart reviews and check this, this per phenotype. But, at least in a phenotype specific way, we've done it, we quantify that over, with chart reviews. I mean, we.
Yeah, we've done stuff with deliberately putting noise in and trying to see, can we get the truth? Even with just setting up, toy problems, and it's really challenging. So without some ground truth, it's very challenging.
So, so based on this today's discussion so far, if we want to focus, if you want to kickstart a phenotyping work group, what topic area do you think we should tackle in the first month or the first quarter of 2021?
Gowtham, I think there's only 1 minute left. Do you want people to answer this on the chat as we exit this, so we can be ready, you can be ready, or we can get ready for the next session, next meeting?
Yeah, so there is a work group for phenotype development and evaluation that has its own Teams environment. So I know I'm seeing several new faces that are joining this that I haven't seen become an active part of that conversation, but I think that would be a great place for us to try to stimulate, since we haven't had a consistent phenotype work group that's been going on. Trying to get some alignment on some topics could be a really great kickstart to 2021. I think that would be wonderful.
Are we meeting on bi-weekly, monthly? Or is that yet to be determined with the phenotype kind of rebooting this group?
Yet to be determined.
Yeah.
Maybe every 2 weeks would work.
Maybe, well, it's possible. Let's follow up as a group conversation after this meeting in the forums, propose it and see what the feedback is, and then let's set up time.
And if you are not on the actual Teams groups now, please let us know so we can add you.
Yep, it'd be great to get everybody on.
Thank you, guys.
Thank you, everybody.
Great
Can we go
meeting.
back to the main symposium now? Or the main meeting?
Nope, we're all done.
Okay. I have no idea what's happening. Okay, thank you.
See you.
Have a good one.
Bye.